I'm Alex Brown, and I'd like to introduce you to the Joist Wizard Design Tool. This tool takes your joist span, slope, and special loading and analyzes that to tell you the most economical depth. The Joist Wizard also provides estimated joist properties for the various depths, including weight, moment of inertia, width, bridging, and maximum allowable duct size. Let's jump in. First thing you may notice are these three sections here: specifications, uniform loads, and uplift. The specifications are going to get at sort of the physicality or geometry of the joist. It's like the span, if there's any kind of a depth limit, yes or no. If yes, you can enter that information here. The tributary width or the spacing of the joist, and then any kind of a live load deflection limit. Uniform loads, there's just a few options here, so dead plus a couple of live options. If there's a different load present, that may be something that advanced mode is going to be good for. We'll look at that in just a minute. And then at the bottom here is this uplift section. So it's going to default to gross, so 1.0 wind load, and then whatever my magnitude is. Or you can punch in a net uplift force, which is what we would design for ultimately. So you can see that's the ASD load combination there, 0.6W plus 0.6 dead. If I was designing this project in LRFD, or if I wanted my joist supplier to design that way, I can go ahead and toggle that over here in the project info section. So that defaults to ASD, but that can be swapped to LRFD right here. Similarly, load types can be changed: ultimate versus service, which is going to affect some of the wind and seismic factors that are being applied, and then ASC 716 versus 722. So all of that is controlled here. That would actually impact the material design of the project. And then there's also this project info up here, so the project number or design mark. This is for your use. These are all optional inputs. And really, it's just to translate to the final generated report so that all of your designs here in the Joist Wizard sync up to any other project calcs that you may have. So I want to change the joist type here from standard to composite and just talk through this real quick too, because this tool also supports composite joist design, and we're very excited about that. So specifications, this section looks pretty much the same. The slab section is brand new. So this is going to help define what type of deck and the type and amount of concrete that's being kind of applied to this joist, and that the joist design can lean on compositely to help complete its design. And then the uniform load section here looks a little different as well. Superimposed dead load is the input here. Self-weight of deck, joist, and slab will be calculated during analysis. Does not need to be included here. The superimposed live load that's being designed for, and then any particular construction live load that you wish to design for. So switching back to standard, let's go ahead and check out advanced mode. And that's going to be this toggle up in the top right here. Right away, lots of additional options. Starting in the specifications section here, this entire middle row is brand new. So now I can control top chord extensions on the left end or right end, the slope here. So that'll be factored into the final design outputs that the tool gives you for things like seat depth. If there's a minimum moment of inertia that's required for this joist, that can be entered, and all of the joist properties will be upsized accordingly to make sure it meets that. Uniform loads, there's a few additional options here. Uplift, I want to take a second to kind of talk through, because there's this additional option here for uniform versus zonal. So if I had a joist that was maybe at the perimeter of the building, so I had a higher uplift force at the end of it, maybe going partway into the span, and then a lower uplift force for the rest of the span, that's all controlled here. And that's mainly with the A and L inputs here. So the A dimension is going to be where that load starts, and then the L dimension is how far off of that point the load continues. So if I did have like that heavier, lighter, perimeter scenario going on, this first row, my A dimension might be 0 with a 10-foot zone going across the joist span. And then for the lighter loading, my A dimension would be 10 foot to start at the end of that and then continue on through the end of the joist. So distributed loads works pretty similarly using the A and L dimensions to sort of control where it's located in the joist span. But now we've got a WS, so the starting weight and the ending weight. So this is going to be good for maybe a snowdrift load or some sort of a triangular rain load or a non-uniform ballast. Anything like that can be controlled here with the different load types. And if I have additional loads, I can hit the plus arrow to add rows, or if I want to delete some of them, I hit the minus button here to remove the selected rows. Concentrated loads, again, kind of a similar look and feel to this one. You can enter that point load magnitude, P in kips, and then the A dimension in feet controls where that's located along the joist span. And then maybe if I didn't have that A dimension, let's say a mechanical guy hasn't gotten back to me on where that unit is going to be located, I can hit this checkbox here to make it an add load, where the Joist Wizard will figure that per Steel Joist Institute guidelines as an add load. It'll be checked at every single panel point along the span and designed for the worst case location. And then finally, axial loads and end moments. This gets into the lateral forces that could enter into a joist. And the important part here is specifying the correct transfer method. So it's going to default to other, and that's kind of a catch-all for any sort of like a knife plate, tie plate, strap, angle, bar, anything that's going to connect one joist to the adjacent joist and help transfer any kind of an axial load or end moment load in and out, bypassing the joist seat itself. If none of those supplemental pieces are present and you are relying on the joist seat to transfer that load in through the bearing, that's fine. You just make sure that's selected here as the appropriate method. And then there's some guidance here on what the maximum allowable forces are for each transfer method. So let's go back to basic mode and actually start entering an example to work with. So when I toggle out of advanced mode, it gives me this warning here that it will clear all advanced inputs. Are you sure you want to do this? Yep, that's fine for right now. This information will be saved between the two modes, but yeah, as that warning said, going out of advanced mode, you will lose those advanced inputs. So let's go ahead and figure a 42-foot span. These joists will be 8 foot on center and kind of a lighter design loading here. Let's go 15 dead, 15 live. So with pretty minimal inputs, pretty quick and easy to punch in here. That analyze button lights up, and now I'm able to see these estimated properties for all of these different options. Right away, my eye is drawn to this big green bar going across the middle of my list here for the 30-inch K-series option. So 30K, 240 over 120, so 240 PLF total, 120 PLF live. This is my most economical option for this particular scenario. My cost ratio is 1.000, so it's batting 1,000. And then all of these other options, the cost ratios are pegged off of that. So if I go shallower, let's say to a 28-inch option, I'm paying a 2.5% premium to get that joist versus leaving it at 30 inches. And you can see some of these get pretty dramatic. 44 LH option, you're paying almost 150% compared to a 30K equivalently loaded option. And what's interesting here, it's a little counterintuitive. This is actually slightly heavier of an option at 1.5 PSF compared to some of these that are only 1.4. But again, that's kind of the magic of this tool, giving that as a cost ratio, trying to give you that fine level of detail so you can make a truly informed decision for what's most economical for a project. And then going across the top here, all of these column headers are sortable. So you can sort by ascending or descending order. And then moment of inertia is just an estimated moment given that depth and the estimated chord sizes. Live load deflection ratio, this is going to give L over 472. Top chord width, you can see 5 inches going down to 4 inches is probably what's generating some of that weight difference and the cost difference. Expected bridging, expected seat depth. This is pretty straightforward, just 2.5 inches being tied in with a K-series. And then maximum allowable duct sizes shown for a round, square, or rectangular size. At the bottom here is this equivalent uniform load section. So this is going to be pretty cool. So it's showing all of my LRFD load combinations here. And you can see just dead plus live basically is governing because I don't have any wind loading present. So I'll go ahead and select that first one. You can see the equivalent uniform load here, and then the reactions, as well as a shear diagram and moment diagram. And then one thing I'll point out is that these are unfactored loads, because that's what we would design for in the end. Even though LRFD was selected, we were doing this 1.2 and 1.6 amplification in the background and designing accordingly. but that would not be reflected in the designation. That's just something that we would design for on the back end. So once I have all this information punched in and like I'm really happy with a 30K option here, what can I do to save this information? Two different options. First is going to be the Save Record button. So what this does is generate a unique record key here, and then I can go ahead and copy that. It's copied to the clipboard of my computer, and I'd be able to load that back into the tool, or I could send it to a colleague perhaps, and they could punch it in and look at the tool and kind of be seeing the same thing that you are. So this is good for like really hefty examples with a lot of, maybe complicated inputs, just to save that time from having to re-enter all of that information manually, tediously. Alternatively, if I just need something for like my project calculations, I can hit this Generate Report button here, and that takes me to this dropdown with all the different designation options. So if I was happy with that 30K option, I could select that here, generate that report, and then that creates an Excel file that I can open, and it has all of my inputs and outputs. So let's go back to the inputs here, and I'll go ahead and refresh the page just so we have a completely clean slate. I want to show loading that project real quick here. So that's the button up top, Load Projects. And if I just paste that record key in here, you can see that it pulls up all of my same information, the 42-foot span, 8-foot tributary width, etc. But let's get into something a little more interesting, a little more advanced. And let's actually do a composite joist design example. So I changed that joist type there to composite, and let's figure a 75-foot span. These joists will be 10 foot on center. And for the slab, let's assume that this project is located maybe out west, where it's using a W3 deck supplied by our Verco division. So that's a 3-inch composite deck with 3 inches of normal weight concrete on top. And then the stud cost here defaults to $5 per stud, but if I had better information, maybe more specific to my region, that could be entered here, and then that would be factored into the cost ratios that are provided at the end there. For superimposed dead load, we'll just figure 15 PSF, and I know that the self-weight of everything, the concrete and the steel and all of that, that's being taken care of in the background. 150 PSF live load, maybe this is kind of a heavier assembly area, something that we want designed for that heftier loading, and then 25 PSF construction live. So with all of that entered, we can go ahead and hit Analyze. And then these estimated properties look a little bit different for a composite design versus a standard design. It's mainly in the designation here. It's a 3-part designation instead of the 2-part. So total load is the first, the design live load, and the design composite dead load. So those are the 3 parts there. My cost ratio, structured very similarly. So my 72-inch deep composite joist option here is my most economical, and then all of the associated properties are printed off here. One difference compared to standard is shear studs is now presented as an option. So that gives a quantity and size. So 3/4 inch shear studs, 60 of them along the joist span. But let's get into advanced mode. And let's add some special loading to this guy, just to see kind of what this tool can really do. So if I had a 1 kip load hanging off of this, type dead is fine. And for the dimension, maybe I don't have that information yet, so I'll make that an add load, and it'll be figured in the worst case location along the joist span there. And then for the axial load, this hypothetical was in the West Coast, I said a minute ago, so we'll figure a seismic load, 15 kips, transferring through the joist seat. So that'll upsize the cord and the joist seat calculations under the hood, make sure all of those properties are accurate in the final report. And we'll go ahead and hit Analyze here. So a big difference from a minute ago is that the designation now just shows SP, because the 3-part uniform load designation really doesn't encompass the axial load or the added concentrated load that's present in this design. And that's pretty realistic for what we would expect as a joist supplier. If that was the case, we would want to see that in perhaps a load diagram or a schedule or some sort of a special call out rather than just blanket equivalent designation, because we want to ensure that the joist is designed accurately for the expected loading. And you can see with that added loading, it actually tweaked what our most economical depth would be for the scenario. Now 80 inches is kind of our most economical option, with the 72 inches that we were looking at previously being about 2% more expensive. And that's the Joist Wizard. It's a great resource for seeing what kind of joist will be most economical for your unique conditions and special loading. And with that, happy specifying.